We will now analyze and sketch the graph of f of x equals x plus 32 by x squared by determining the following information related to the graph of f of x. That is, we'll be determining the intercepts relative maximum and relative minimum, points of inflection, and also the equation of asymptotes. So first, let's determine the intercepts. We'll be determining the two intercepts, that is x-intercept as plus the y-intercept. To find x-intercept, we replace f of x equals 0 and solve for x. To find y-intercept, we replace x equal to 0 and solve for y. Basically, those gives the x-intercept and y-intercept. So let's consider this given f of x. This equals x plus 32 over x squared. We are going to find the x-intercept first. For that, I'm going to replace f of x equal to 0 and solve for x. So therefore, this becomes 0 equals x plus 32 over x squared, or we can simplify this to x cube plus 32 divided by x squared equals 0. Multiplying both sides by x squared, we get x cube plus 32 equals 0, and then subtracting 32 we get x cube equals negative 32. So we now take cube root on both sides so that we can solve for x. We take the cube root, and x cube cube root of x cube is x, and we can plug this into the calculator, and when we do that we get approximately negative 3.175. This is rounded to three decimal places. So therefore, we see that x-intercept is negative 3.175, and then y is 0. So this basically is the coordinate or the x-intercept. Now let's see if we can determine the y-intercept by plugging x equal to 0 and determining y. So we can utilize this f of x. We plug in x equal to 0 and determine f of x. So we get f of 0. This equals 0 plus 32 divided by 0 squared. And so this is undefined, as 32 by 0 is undefined. This is undefined, or infinity. So we can see that there is no y-intercept. We will now determine the relative minimum and relative maximum of the function. To find the relative minimum and relative maximum, we should find the first derivative of the function f prime of x, and we should set this up equal to 0. That is, we should first find the critical point of the function and create a sign chart for the first derivative of f of x. Using the sign chart, we can determine the relative maximum or relative minimum of the function. So first, let's find the first derivative of this function f of x. First, I'm going to rewrite this f of x as x plus, I can rewrite this as 1 over x squared as 32 times x power minus 2. Now let's find the derivative of f of x, which is f prime of x. And so this equals the derivative of x is 1 plus we put this constant 32, and then the derivative of x power minus 2 is minus 2x raised to the power of minus 2 minus 1, which is negative 3. Basically, we are using the power rule of derivative to find the derivative of x power minus 2. Let's put this in simple form. So this equals, we have 32 times negative 2 is negative 64. And now we can write this x power minus 3 as 1 over x power positive 3, or otherwise it is 64 divided by x power 3. So basically this expression gives the derivative of f of x, which is f prime of x. We need to set this up equal to 0 and solve for x. So let me set this up equal to 0, and we are going to solve for x from this equation. I'm going to add this expression 64 by x cube on both sides, And when I do that, I get 1 equals 64 by x cube. Now multiplying both sides by x cube, I get x cube. This is x cube, and this equals 64. Now let's take cube root on both sides. When we do that, we get cube root of x cube is x, and cube root of 64 is 4. So therefore, this one represents the critical point of the function. And so using this critical point of the function, we can determine if this represents a relative minimum or relative maximum. So let's create a sign chart for f prime of x. I put this number line and represent this x equal to 4. Now we should take some sample values to the left of x equal to 4 as well as to the right of x equal to 4. Plug it into the first derivative and determine its sign. So let me copy the first derivative, which is f prime of x. This equals 1 minus 64 by x cube. We can take x equal to 1, which is to the left of x equal to 4. Let's plug in x equal to 1 into the first derivative. And so this gives a prime of 1. This equals 1 minus 64 over 1. Clearly, this is going to be negative because 1 minus 64 is less than 0. So we say that it is less than 0. So I'm going to mark negative to the left of x equal to 4. And now let's understand the sign to the right of x equal to 4 by plugging any random values to the right of x equal to 4. Let's say I plug in x equal to 5, and so this gives f prime of 5. This equals 1 minus 64 divided by 5 cube will be 125. And clearly this is going to be less than 1, which is in decimals. So if this is less than 1 and we subtract this from 1, this is going to be a positive quantity. So to the right of x equal to 4, we see that the sign of f prime of x is positive. And this means whenever the first derivative is negative, we see that the function is decreasing. So we can draw the graph of f of x as like it is decreasing. And at x equal to 4, we already said that the first derivative is 0. So we say that it is having a sort of a horizontal tangent. And then afterwards, it is positive. So it's going to be like an increasing function, which means we can now clearly see that the graph of f of x will look like it is having a relative minimum at x equal to 4. So therefore, we confirm that relative minimum at x equal to 4, or otherwise we can write the coordinates of the relative minimum. That is, we need to find the y from f of x. So let's put x equal to 4 into f of x to determine the y coordinate. So therefore this becomes f of 4 equals 4 plus 32 over 4 squared, and this gives 4 plus 32 over 4 squared is 16, and so this becomes 4 plus, we can cancel this as 2 times 4 plus 2, and this gives 6. So f of 4 equal to 6, which is the y coordinate of the relative minimum. So we can just write down this relative minimum in terms of coordinate as x comma y, and this equals 4 comma 6. So therefore we say that the relative minimum of the function is 4 comma 6. Also, this means there is no relative maximum because we got only one critical point of the function, that is at x equal to 4. So therefore we see that there is no relative minimum. I'm sorry, relative maximum. We will now determine the points of inflection of the graph of f of x. So for that we need the second derivative. So using the first derivative of f of x, we will find the second derivative. So let's differentiate the both sides with respect to x, and so we get f double prime of x, and this equals the derivative of 1 is 0, minus 64 times of the derivative of x power minus 3 is minus 3x power minus 3 minus 1, which is minus 4. So basically this gives, we will multiply these two, that is negative 64 times negative 3, and this equals a positive 192 multiplied by x power minus 4, or otherwise we can write down this as 192 over x power 4. Now we need to set this up equal to 0 and solve for x. So that is, we have to set up the equation f double prime of x equal to 0. And so when we do that, we get 192 by x power 4 equals 0. And this one does not have any solution. And so therefore we see that there are no points of inflection. We will now determine the asymptotes from the function f of x. First, I rewrite this f of x as in terms of a rational function form. So I can multiply this x with the common denominator is x squared. So therefore, it will become x cube divided by x squared plus 32 by x squared. And so this becomes x cube plus 32 divided by x squared. So basically, this is in the form of a rational function. So now to find the vertical asymptotes, we should set up the denominator of this function to 0. Vertical asymptotes, we should set up the denominator, which is x squared. So x squared equals 0, and this means x equal to 0. So therefore we see that the equation of vertical asymptotes is x equals 0. Now let's determine if there are any horizontal asymptotes. So let's consider the equation of the function f of x equals x cubed plus 32 over x squared. We set the limit x to 0, limit of f of x. That is limit of f of x when x approaches positive infinity. And so this gives a limit of x cube plus 32 over x squared when x approaches infinity, or otherwise we can also write this in the form which is given, that is x plus 32 over x squared. And so when we apply this limit, when x approaches infinity, this quantity becomes 0, because a number divided by x with x approaches a larger number, this quantity basically becomes 0. However, we have this x, so it approaches infinity. And similarly, we can also determine the limit of f of x when x approaches negative infinity. And so this becomes a limit of x plus 32 over x squared, x approaches negative infinity. And here also this quantity will also become or approach 0, and we have this x, so this will approach negative infinity. So we see that in both cases we are seeing that f of x approaches positive or negative infinity, which means there are no horizontal asymptotes. It does not approach a finite value. So we say that horizontal asymptotes is none. Okay, since we have determined that there are no horizontal asymptotes, let's check if this one has slant asymptotes. For that, I'm going to write f of x in the form, that is x cube plus 32 over x squared in the rational function form. Now we can see that the degree of the numerator polynomial is 3, and then the degree of a denominator polynomial is 2, because we have the term x cube, which is the largest x term. So we said the degree is 3, and in the denominator we have the term x squared, which is the largest x term. So we said degree is 2. And this one is the degree of the numerator polynomial is 3 minus 2. It is exactly 1 less than the degree of the denominator polynomial. And so whenever this happens, we see that it has a slant asymptote. And so once we have determined the slant asymptote, we can perform the long division to determine the slant asymptote. So let's do that. We have this rational function x cube plus 32, and this has to be divided by x squared. We consider this x cube divided by x squared. That's the first term in the divisor. And so this gives x. So I put x, which is x squared. And then I bring down this 32, which is the remainder. So therefore, we can now write f of x. This is the quotient. So x plus, and then the remainder is 32 over the divisor, which is x squared. This form is already given in the question. However, we have demonstrated that this is how we have to determine the slant asymptotes. Once we figure out that the degree is exactly 1 less than the degree of the denominator polynomial. And in this case, we particularly consider this one, that is a quotient polynomial, as the equation of the slant asymptote. So therefore, we say that y equals x is the equation of slant asymptote. Okay, here we have drawn the sketch of the graph of f of x using the information that we have already determined. That is, we first mark the x-intercept, that is negative 3.175, comma 0, and there is no y-intercept. And at x equal to 0, we have a vertical asymptote. So we should draw the graph of around this x equal to 0 as like this. That is, it is approaching 0 only when x equal to infinity, like that. It is when y approaches 0, x becomes 0. That's what vertical asymptotes is. And we also draw the graph of the slant asymptotes. Slant or the oblique asymptotes, that is y equal to x. So using this slant asymptotes and also the relative minimum at 4 comma 6, we also know that the function is decreasing to the left of 4. So we draw it like this, that is, it's actually coming from the larger values of y, and it is decreasing and then decreasing to the point till 4 comma 6. After that, it increases and it approaches like it approaching the slant asymptote. And here also we have to draw the graph as such. It is approaching the slant asymptotes y equal to x. So this is what the sketch of the graph of f of x. And this can be demonstrated by using the graphing utility. So let's utilize the graphing utility and draw the sketch. And we can clearly see that it almost looks like this one. This is the actual graph of f of x using the graphing utility. You can clearly see that it is having a relative minimum at 4 comma 6. This is the x-intercept, and this one is the slant asymptotes, that is y equal to x. And here it is decreasing, and this one is also a vertical asymptote at x equal to 0.